Good afternoon, everybody. My name is Wayne DeCosta, the Applications Engineering Manager here with Fujitsu General America. I'd like to welcome you to our third installment of our Virtual Product Exposition series. So today is VPX3, the third for 2025, and building upon VPX2, where we introduced you to A2L refrigerants and the prescribed methods for the ASHRAE safety standards. We're going to take that to practical application and show you how you can use Design Simulator to make all of this happen, to make sure that your refrigerant charge for all of your systems are in compliance. So what are we going to be talking about today? Well, Design Simulator and H series. We'll jump into LDS, what that means, our different kit accessories. We'll get into some Design Simulator scenarios. So we'll explain how those are assembled and arranged through Design Simulator. And then we will talk about how to use the information for an MREL calculation. So we will discuss what all of those details mean. Now, some of you Design Simulator veterans may look at this image on the right and say, wait a minute, something looks a little different here. What are those bow tie things? So those are our shutoff valve accessory options. Again, so we will divulge all of those details today. So sit back and listen up. We've got a lot of good information to go over, to include how to use Design Simulator to qualify the system to determine the need for any A2L mitigation, or as it's verbiage in Design Simulator, VRF safety measures. So we can use, again, the software to confirm that our charge is going to be compliant or not. And if not, what countermeasures can we do to make sure that the charge is in compliance? So what is Design Simulator, first of all? Design Simulator is not a load calc program. It is an equipment selection program. It is actually designed and maintained through the Fujitsu headquarters in Kawasaki, Japan. And it is the one and only official Fujitsu General Limited software that's used for equipment selection. Now, of course, we have other tools such as Infinite Comfort Pro. However, Design Simulator is a full-blown selection program that allows you to generate, of course, a complete bill of materials. It allows you to actually set your design conditions, and the software will interpolate the capacities based upon those indoor and outdoor temperatures. We're going to be focusing on the refrigerant charge data, and directly related to that would be the piping diagrams. We'll dive into a little bit about the electrical, and then the controls and the additional options. So as you can see on the center inset for a single zone, and on the upper right we have multi-zone, which means, yes, Design Simulator is fully compatible with H-Series single and multi-zone. Let me say you don't need to be an engineer to use Design Simulator. As a matter of fact, even with the most basic of computer skills, with about an hour's worth of training, you can become proficient with Design Simulator in probably, again, about an hour worth of training. So as I mentioned, we're going to be focused on the piping and refrigerant charge sections today because, of course, piping will have a direct effect on the total refrigerant charge. So as you see here, we can go ahead and anticipate. Now, this is a very basic entry, but we can anticipate what the refrigerant charge will be if we can put in an estimated pipe length. So we can use Design Simulator effectively for the planning phase to make sure that the refrigerant charge will be compliant with the safety standard. And we can create countless, quite literally infinite what-if scenarios. So in this case, we have a 21-foot vertical separation. The overall pipe length will be 78 feet. So we will, again, dive into all of these details. And let's talk about LDS for a moment, because you hear this term a lot and you may wonder, well, what the heck is LDS? You probably heard the term RDS. So LDS is really the same thing. So LDS is the term that we use, leak detection system. And although we call it a system, it can be comprised of a single component. Leak detection system could be just a gas sensor. It could be a gas sensor and a shutoff valve kit. It could be a gas sensor and just an expansion kit if we're going to control, say, ventilation only, or it could be a combination of all three. But if you look at the table, H-Series only has one LDS component, which is the wall-mounted gas sensor. That's it. So we do not have shutoff valves or expansion kits for H-Series systems because our charge quantities don't really warrant it, and we'll see that. So it's important to understand that air-stage ducted units include, in capital letters there, a factory-installed leak detection system, but it's the gas sensor only. It's an internal mount near the coil. It is not the wall mount as you see, but we can apply a wall mount gas sensor even with a ducted unit. So we'll take a look as far as when and why we would need to do that. Piping diagrams. This is huge. We want to take a look at the refrigerant charge in the system and determine whether or not we need to factor for dispersal volume calculations. Sounds like a big word, but all we're talking about is effectively the smallest room's length, width, and height, but dispersal height. So we'll talk about that a little bit more. So in this case, we see the outdoor unit comes pre-charged with just under 4.5 pounds of refrigerant. So we know we are over the 4-pound threshold. And let's just say we put in an estimated or an actual 78-foot length for our line set. We can see that we've exceeded the pre-charge length. So we need to add about 1/3 of a pound in addition with a total charge of 4.77 pounds. So what do we do with that number when we have it? So we know system is going to have let's just say 4.8 pounds, round up. What do we do with that? Well, if you remember from VPX2, we introduced this application bulletin. This is an excellent resource. I would highly suggest that as a contractor, you probably want to have this printed out and quite literally laminated and have it with every single installer. Just make sure they understand how to use this table because it's very easy. So let's just say for this particular system that we have the smallest dispersal area is going to be 150 square feet. If we look at the chart, the row that says 150 square feet, we can see that at a 4-foot ceiling, the max, that's our maximum system charge, that a 150 square foot area with a 4-foot ceiling, I don't know of too many 4-foot ceilings, but, or should I say 4-foot dispersal height. So there's a good point to note. This is not necessarily ceiling height, dispersal height. That is, what is the lowest point at which the supply air is going to exit the indoor unit. So we're talking here non-ducted specifically. In this case, let's just say with 7 feet, we see that at 7 feet, our maximum allowed refrigerant charge is 10 pounds, but we're less than half that. So our refrigerant charge is compliant with flying colors. I'm waving my hands here in the air, but you can't see that right now. So, so when the installation complies, more specifically when the refrigerant charge complies with the safety standard, and LDS is not required. So on page 3, 4, and I believe even 5 of the application bulletin, otherwise known as a cheat sheet, which we call it internally, there is a table, or there are tables, plural, that have our single zone, multi-zone for H series as well as J series. Now you can see the factory charge amount, and then if we look on the far right column, the maximum pipe length, and hypothetically, if we maxed out the refrigerant line length for every system, what that refrigerant charge would be. So you have a quick at-a-glance means of knowing what system am I going to be proposing, and will I need to consider any LDS accessories, or will I need to do any dispersal volume measurements. And what about factory options? You know, considering I deal with AIRSTAGE all day, every day, I still don't have our options memorized. So which is, I rely 2% on memorizing the content, and the rest of the other 98% is remembering where to go. So by the way, speaking of accessories, our controls engineer put together a phenomenal spreadsheet, which is available in Access, which is a document that you can download, and you can sort the data, and you can find every single available option for both indoor and outdoor units. Well, guess what? It's also provided a little bit abbreviated by comparison, but it's available through Design Simulator as well. So we can see we have indoor and outdoor unit accessories. In this case, for example, if we had an ARUH36, if it was a medium static ducted unit, we can see we can select if we wanted a TTRX as well as long life filter. Now it's important to point out the allowed options section here, because this is what we're going to be focusing on later in the presentation. So it's compatible with single zone, as we mentioned, and one of the really neat features about Design Simulator is if you're doing load calculations, which you should be anyway. Every project should have a load calc. Now that's a 3-day topic unto itself, but let's just say for the sake of argument, you do your own load calcs, you perform load calcs, and you want to enter in your design conditions, your indoor dry entering, your outdoor dry bulb for heating and cooling, and you enter in your total, sensible, and heating capacities. Design Simulator can actually select the equipment for you when you select the equipment type. Or you can do, which is what most people do, is you do a manual selection, but still it will interpolate the capacity data based upon your design conditions. For example, we know that AHRI 210, 240, that's when we say we have a 3, 4, 5 ton system. But let me ask you, when you think about the rated conditions, it's 80 degrees indoor, 67 wet, which is 50% relative humidity, at 95 outdoor. How many of you actually designed to an 80-degree indoor temp for summer? Probably never. And likewise, customers, do they actually run their systems at 80 degrees? Probably not. Some may, but very few don't, or very few do rather. Typically, they'll run it like 75 degrees or maybe even cooler. So the Design Simulator software will allow you to provide actual interpolated values from the design and technical manual cooling and heating capacity tables based upon your actual design conditions. So that's huge. And what about memorizing the product numbers and available capacities? Do you have that memorized? I sure do not. So it's a better idea, this big light bulb right here. So what happens if you click on this large light bulb icon, it will pull up every single system that we have. And you can, in your configuration settings, you can tell it to display all of the systems that have been around since AIRSTAGE was introduced into North America, or only the current production systems. So let's just say for argument, we've got the current production systems. This will pull up all of the available. Now, if you select just, for example, the medium static pressure, medium static ducted units, KUAS, the small icon here will pull up all the available capacities. So let's take a look. So if you were to click on this large light bulb, this is what it pulls up. You see a complete table of all the available unit types, their model series, and the available capacities. So if we intersect the 36,000 BTU column with the medium static row and say, oh, this is what we want. So the available capacities have the dot within the box. So if we were to select this box, click on it, it will go ahead and pull up the first screen here, which has the equipment, and that's where we could enter if we want other design temperatures, enter our refrigerant piping length, and so on. So that's it for single zone. Now, what about multi-zone? So what we're going to do here is typically for my presentations is we start off easy and then build upon the knowledge that you gain, and we'll work progressively more towards a more complex and challenging structure here. So good work for your brain. Good training builds character. So what about multi-zone systems? Absolutely. It's 100% compatible with multi-zone. And I would highly recommend using Design Sim for H-Series multi-zone. Yes, we have quick select sheets that show what goes with what, which are excellent. However, what we can do here is we can account, again, remember the main focus is the refrigerant charge. That's critical. So we can enter in estimated lengths during the planning phase, and we can come back and enter our actual lengths to have a complete as-built for permanent record. Now, this also makes sure that you are allowed only the available capacities per port. So Design Simulator is a backstop that will not let you make an error in the equipment selection. So once in a while, we do hear about a misapplication, and that's usually not a pleasant scenario because it involves a significant amount of time and money to go back and correct. So if you can map out a multi-zone system in quite literally about 10 minutes or less, that 10 minutes could help prevent thousands of dollars and of corrective action afterwards. So we highly recommend using Design Sim for multi-zone systems as well. And what about this? Don't you think this is a nice printout that you could print this out, hand it to your installers, and they know exactly what goes where in terms of the piping. You can provide estimated pipe lengths. They can cross it out and put in the actual, then we will have a permanent record of the actual refrigerant charge. So there's no guesswork on the pipe diameters or what unit goes where, which connects to what port. And the max refrigerant, or should I say the additional refrigerant here in this case, because we've exceeded the pre-charge length, so we require approximately a quarter pound of extra refrigerant. If we take a look, the pre-charge in the unit's 3 pounds. Because we've exceeded the pre-charge amount and of our piping length, it's about a quarter of a pound extra. And if you look on the right, we are less than just under 3 1/4 pounds of refrigerant. So even with an AOUH 45 multi-zone system exceeding the pre-charge length of the piping, we're still 3/4 of a pound under that 4 pound threshold. So as I mentioned, a huge majority of the time you will not need to worry about LDS accessories. And even when you do, again, a gentle reminder that our ducted units H series and J series have a factory installed leak detector. So we'll talk about that more. Referring to an earlier screen, we talked about how Design Simulator creates a bill of materials. So this is great, for example, so you can group single zone, multi-zone, even VRF projects into a single report. And this is a report, for example, if you wanted to, as a contractor, you could save it, email it to your distributor and say, I want a price on everything here. So it's a great accessory. And what about piping too? So we talked about equipment, but piping in terms of additional refrigerant, but what about materials? So the first one here is for the multi-zone system. We see that we need 181 feet of 1/4 inch, 136 at 3/8, and 45 feet of 1/2 inch. So likewise, we've got the 2 multi-zones below it, 1/4 3/8 and 1/2 5/8. So this is going to help you estimate how much material you're going to need for the project, as well as when you go to pull the material for the job, make sure that your installers know how much that they need to bring to a project so they don't bring too much or too little. What about electrical work? Do you perform line voltage electrical work yourself? Do you tap into electrical panels and run your own line voltage wiring, or do you sub it out? Either way, if you have a contractor that you work with, how convenient is it if you can print out this Design Simulator report that shows the electrical? Again, it knows, it shows exactly what goes where. It shows the minimum circuit ampacity, max overcurrent protection. It doesn't allow for a mistake to occur. Now, granted, the electricians are going to do what they need to do anyway, but again, this is just a nice roadmap so they know what goes where. Now, let's talk about VRF safety measures. So if a refrigerant charge is not compliant with a safety standard, what do we do? Well, how do we know if it's even going to be compliant? Well, there's also the equipment safety standard known as UL 60335, of which is with what the Design Simulator factors and quantifies as VRF safety measures. Now, this is available through a room setting function. And how that works is when we get a project together, we will go ahead and enter all of our piping lengths, and it will automatically tabulate the total refrigerant charge, and we can determine based upon the room areas whether or not any type of mitigation action is required. So as I mentioned, first thing you want to do is make sure your piping lengths are entered to make all of this happen. So where the VRF safety measures are obtained is through the room setting feature, which is initiated through the detail tab in the upper right of your screen. Once we select the detail tab, by the numbers, we can go to the floor setting, and I list that as optional. If you only have one system, you don't need it, but if you have, say, 2, 3 systems in a home or in any given project, it helps you sort what units go to what system. For example, just keeping it simple, if you had 2 separate systems, upstairs, downstairs, you could do that, for example. Number 2 is to add a room. So what we're doing is we're going to basically replicate or add rooms of which we're going to assign the indoor units to. So 3 and 4, we can enter in the room dimensions, and number 5 is the actual ceiling height or dispersal height, and the area and volume are calculated automatically at that point. Going down to number 6, indoor unit allocation. So go ahead and configure all of your rooms first, And then what we will do is we'll go to the allocation screen, which basically allows you to assign an indoor unit to the room that you created. So for example, number 1 was selected already. So for zone number 1, we went ahead and entered the room length, width, and height, which was 10 by 10 by 9. And we assigned the AIRUL 004, so the 4000 BTU unit to it. So once you allocate a room, it will populate in this section. So moving on to the second zone, so you would highlight the zone by the numbers, number 1, number 2, you would select the indoor unit that you want to allocate to that room, click the allocate button, and again, it will populate here. Now repeat that process until you assign all the indoor units to all of your rooms. And then we'll go to the close button on the bottom right. And this is where it really gets good. When you click close, it will go back to the room setting screen. And you'll see these 3 columns, the response measure 1, 2, and 3. So these are the VRF safety measure results. So zone 1, based upon the total refrigerant charge, it says that we definitely need indoor air circulation. So how is that triggered? That's done through leak detection. So what response additional measure do we need? We need either ventilation or shutoff. So it's not going to tell you which one to use because it's actually at the discretion of the system designer. You can use just ventilation only. That may work, or you may use a shutoff valve only. So if you look at zone number 2, and I highlighted that in green because it's passed, it says no required measure. So we can see by the room, so we see that zone number 1 and zone number 3 do require some type of mitigation. So we know we need to go back and take a look at that. Now you can also, if you see the checkbox here, it says select 1 to an indoor unit in the room which required safety measures. So this is an auto select. So in other words, if you click this box here, any room which requires air circulation, it will go ahead and automatically assign a leak detector to it, a wall mount leak detector, and we'll talk more about that. So let's take a look at our LDS components. We have 2 shutoff valve kits. We will take a look at that. And we have a gas sensor, and we also have an expansion kit. And don't worry about memorizing these part numbers. We will definitely get into this here shortly. And this is what we will do. We will see what these items are, when they are needed, how they are selected, and most importantly, what goes where to make sure that we can revise our piping structure so we can determine our maximum releasable charge. Now, let's start with the shutoff valve. What are they? Those of you that are familiar with VRF may look at this and say, I know what that is. That's an RBU that we use in heat recovery systems. It looks like an RBU, smells like an RBU, but guess what? It's not. It's a shutoff valve kit. Now, it doesn't use solenoid valves like the RBU does. However, it uses EEVs that will be either fully open or fully closed. That's it, one or the other. Now, there are actually 4 lines to this, 2 in and 2 out. A dedicated line for the liquid and a dedicated line for the vapor. So it also has a capacitor PCB in case of power loss that will drive the EEVs close. And I thought it would be a good point to note that the capacitor PCB's got a 13-year life expectancy. So now there are 2 models, as I mentioned, and they are selected by capacity and where they are placed in the system. And those we will talk about. So expansion kit, UTZ-JUXA, there's only one. This is used anytime we have what we call a partial shutoff. The piping structure, we'll talk a lot about that here coming up. Also, it's a ventilation interface, what I call a wiring hub for our ventilation. We have a means for an external input for ventilation, which is really for a ventilation system failure. We'll talk more about that. And then we also have a ventilation output as well as an alarm output. Now, I would like to say we call it an expansion kit, but think about expansion in terms of the wiring. It does not infer any type of refrigerant expansion, as in like pressure differential through an expansion valve. No, it doesn't have any piping to it. It's wiring only. The gas sensor kit, you can say, well, wait a minute. I thought you said that the ducted units come with a gas sensor. Well, they do, but it's internally mounted and it's near the coil. It does not look like this. This is an optional wall sensor that is installed not greater than 1 foot from the ceiling. Yes, so we will talk about that. So it's a wall mount sensor. It can be used with or without a shutoff valve kit. It's got power and alarm indicators. It can connect directly to the indoor unit when we have what we call a whole shutoff option by using a UART cable accessory, or partial shutoff. If we're using an expansion kit, it wires directly to the expansion kit. So now we are familiar with what LDS components are, and how the shutoff valve kits are applied is what we call either a whole shutoff or a partial shutoff. Now, you will never see 2 shutoff valves installed in this manner. It cannot be done. That is, you will not have a shutoff valve on the outdoor unit side and one on the indoor unit side, so to speak. It will always be one or the other. So you can have a whole shutoff, which will, as the term implies, isolate the refrigerant charge to, or shut off the refrigerant charge to all of the indoor units downstream. Conversely, with a partial shutoff, it will go ahead and shut off only the refrigerant charge to the indoor unit and piping of which it is connected to. So when the shutoff valve closes, again, it shuts off refrigerant flow to everything downstream. So let's take a look at that. So I just wanted to clarify, when we say whole shutoff, or on the outdoor unit side, compared to partial shutoff on the indoor unit side. So the shutoff valve kit cannot be installed outdoors. It cannot be installed on the outdoor unit, but we say outdoor unit side, so to speak. So when are the items needed? A shutoff valve kit. So it's used to help release, or excuse me, help. We don't want to release the refrigerant charge. We want to reduce the releasable refrigerant charge and to assist with ASHRAE standard compliance. So what we see is a whole shutoff option here. So by comparison, if you look on the lower right, if we have a 9.2 pound system charge, by putting in a single shutoff valve kit, we can reduce that by a little over 1.5 pounds, and that difference alone may make the refrigerant charge compliant with the safety standard. So what's nice about using one shutoff valve is there's no expansion kit required in an outdoor unit or whole shutoff. No expansion kit required. The valve wires directly to the outdoor unit, but the drawback is that has the least amount of refrigerant charge reduction, because you're still allowing a leak for everything downstream if that were the case. So the expansion kit is an interface for the shutoff valve when it's a partial shutoff. So again, we saw the whole shutoff that we had on the quote outdoor unit side, but on the indoor unit side, which is what we have here, this is a partial shutoff. So again, upon a leak event, if this valve closes, the refrigerant charge is isolated to the liquid and vapor lines, the quantity of refrigerant downstream of the shutoff valve to include the indoor unit. So a significant reduction in the releasable charge. Some additional functions is we have the ventilation outputs, as I mentioned, the alarm, and what we can do as an option is for ventilation only. So take your eyes away from the image here for a minute. So if we're not using a shutoff valve, in lieu of a shutoff valve, let's just say we're going to propose some type of ventilation. So we're going to bring in outdoor air for dilution, however, by whatever means. We can do that, and we can do that through use of an expansion kit. So take a look at a D&T image of an expansion kit. It's basically a wiring hub, as I mentioned. So if you look at the green insets, first of all, the one in the center. So in a partial shutoff, we see that the shutoff valve kit is wired to the expansion kit. And if you look at the larger inset on the right, you see that's basically just an expanded view of the terminals of the expansion kit. So looking at the green, we can see on the bottom and P71 where the shutoff valve kit wires. We have the optional alarm out as well as the optional ventilation out. Those of you that are familiar with our AIRSTAGE systems and external output use know that we have a 12-volt output with a 50 milliamp DC max 50 milliamp DC max holding current. However, that is exactly the same with this as well too. So at least we remain consistent there. So a very common relay is a rib relay that we use that meets where the coil meets these load requirements. There's a ventilation input. So what that is used for is if the ventilation system failed for some reason, if we have a change of state and the contacts on the input here, we can go ahead and actually shut the system down, because if the ventilation system failed, we don't want to run our system because if there is a leak and the ventilation system doesn't work, that's not going to be a good scenario. The gas sensor kit, it is compatible with ducted and non-ducted units. It does have, the sensor itself has got a 10-year lifespan on the premise that there is no damage to it. So a leak detection system or a leak sensor is required if we are initiating circulation of the indoor blower. We're using a Shutoff valve kit, as we mentioned. And a reminder here that our H-series and J-series ducted units do have a factory installed gas leak sensor. But again, it is not the wall mount sensor, so we'll see how that comes into play. So what goes where? The shutoff valve kit. So what we're going to do is take a look at a whole shutoff example. Now, regardless of the outdoor unit capacity, even if it's 2 ton, we can see we have 2 shutoff valve kits that are sized based upon downstream capacity. So you can say, well, a 2 ton is only 24,000. Why aren't we using an 027? Shutoff valve kit on the outdoor unit side, so to speak, for whole shutoff is always going to be the 060 model. Wires directly to the outdoor unit, as you see, and it will shut off refrigerant flow to all the indoor units. Connects to the outdoor unit, so no expansion kit is required. It is connected directly to the PCB on the outdoor unit via connector CN590. It's got some push terminals, so there's no additional wire kit that's required for that. And because it's an external input, we can have nearly up to a 500-foot cable length for our external input from the shutoff valve to the outdoor unit. Shutoff valve kits on the indoor unit side, and let me preface that we can use either the 060 or the 027. It depends upon what the downstream capacity is that's going to be connected to the shutoff valve kit. So anything over 27,000 BTUs, we would use the 060. Anything less than or equal to 27,000 BTUs would be the 027. So it's going to be installed at or greater than the dispersal height, for example. So if this is in indoors, we want this at the same dispersal height, if not greater. And again, depending upon where the shutoff valve kit is located, for example. So it's downstream, it's sized based upon downstream connected capacity, but what we can do is use it in a single or grouped indoor unit application. So here we see 2 indoor units that are piped together, and then we see 2 indoor units that are piped together but form a single remote control group. So if we use these 2 for one zone, whereas these 2 are piped together but serving 2 different zones. Either way, the shutoff valve kit will be used for this application. The expansion kit for partial shutoff, as we mentioned, so we can see a pattern here. It's a wiring hub, again, to the indoor unit, and as we noted previously, we can have 1 per remote control group, or even when grouping indoor units, or for a single indoor unit. The gas sensor kit. So when the gas sensor kit is used, when you think about it, R-32 in approximate terms is about 1.1 times heavier than air. So if a leak were to occur, the refrigerant gas would tend to accumulate at the floor level, which is why that when we use the gas sensor, it's important to know during the planning phase, it can be installed, should be installed no greater than approximately 1 foot above the floor line. In terms of radius, how far can it be installed from the indoor unit? About 32 feet is the greatest, so 32 feet or less from the center line of the unit. If it's a wall mount unit, about 32 feet, or not about, it is 32 feet or less, again, from the center line of the indoor unit. If that's not possible due to the configuration of the room, for example, so long as we can be within a 22-foot radius, we can do that. That's allowable. So we've got the 22-foot rule here. Now, one thing to consider with regard to placement of the sensor is we do not want to be in any drafty areas. So near a door or a hallway, near a window, whether it's natural convection or forced convection, like from the indoor unit, for example, because again, if a refrigerant were to leak, we don't want the accuracy of the sensor being disturbed by air currents that could possibly dilute the refrigerant concentration and affect the sensitivity of the gas sensor. Now let's begin to put these components into practical application here. So let's start with a whole shutoff application. So again, we'll start off easy and get progressively more complex. But I think you'll see it's repetition, and once you understand the basics, the rest will just begin to make sense. I'd like to preface this by saying our R32 indoor and outdoor unit selections are the same with R32 as they are with 410A. So when you select units and arrange units and set them up for the wiring, it's basically the same. What becomes different is when you start to look at the LDS accessories. And how the LDS accessories are selected is through the wiring and options tab on the top. Then once that's selected, we will take a look at the options button on the bottom left, you see in the red rectangle. And then you can pull up either the indoor or outdoor unit. So when we look at the outdoor unit, we will see that the 060 is the only available shutoff valve kit option, which is what we want in this instance since we are talking about a whole shutoff. Now there is a prompt that says the gas sensor kit is required, but why is it not listed as far as one of the allowed options? But when you think about it, where is, or should I say, where does the gas sensor get wired to? It actually gets wired to the indoor unit, not the outdoor unit, which is why the gas sensor is not listed. So by simply moving over to the indoor unit tab, we will then be able to select the gas sensor accessory. So we're not selecting a shutoff valve kit for the indoor unit side because we're on the outdoor unit side, since it is for a whole shutoff. So those are the only two components. So once you get it selected properly, it will place the shutoff valve on the quote outdoor unit side for a whole system shutoff. And as I mentioned, the shutoff valve kit is connected directly to the outdoor unit. So, thus, no expansion kit is required. Now, on the indoor unit side, connecting the gas sensor to the indoor unit, in this case, since we are not using an expansion kit, there is an accessory cable that is required, the UTY XWZXZL. So make a note of that. Anytime you use a whole shutoff and you connect the gas sensor kit, you will need this cable accessory. And you can say, well, what, for example, what if it were set so if we're connecting to the indoor unit number 3 instead, it's also a 4,000 BTU unit, and that's a ducted unit, therefore you don't need the gas sensor kit accessory, right? Well, it is actually a mandate. Anytime you select a shutoff valve kit, even with a ducted unit, you are going to need the gas sensor, because when you think about it, the gas sensor that's factory installed in the units may not be representative of where the refrigerant concentration is going to be in order to get the shutoff valve kit to close. So in other words, we need the gas sensor that will be installed not greater than 1 foot from the floor height in order to make sure we have the appropriate safety measure control action to shut off the shutoff valve. Make sure, again, that we enter in all of our piping lengths, because then at this point we can quantify what our revised refrigerant charge is going to be. Now let me clarify that. It's not going to affect the whole system charge. Rather, now what we want to determine is what's the maximum releasable charge. So if this valve closed upon a leak event, how much refrigerant could be lost for all of the downstream piping to include all of the indoor units. So that's what we're looking at. So the term maximum releasable charge, or MREL, is a charge that we're is a term that we're going to become familiar with. So now let's take a look at partial shutoff. Now I think you'll see that there is, again, a repetition to the process here. So we go to the wiring options tab, then options, and then we will select the indoor unit because we are going to have a partial shutoff here. So we will select the indoor unit, for example, indoor unit 1. We go ahead and select the shutoff valve kit, and it lets us know that the gas sensor kit is required. So we can go ahead and add the gas sensor kit. Once we add the gas sensor kit, another prompt comes up and it says, well, you need the expansion kit as well too. You big dummy, in the infamous words of Fred Sanford. So we want to make sure that we add the expansion kit. So in all seriousness, this is an exceptional use of Design Simulator because it will not let you have a misapplication when it comes to LDS component selection. So once you get the components selected, you can validate to make sure you've got what you need, and you'll see that the selected options are displayed down below. Now, okay, so that's a partial shutoff, just for one indoor unit. Now what we can do is factoring, well, let's take a step back here. For discussion purposes, let's say that indoor unit 2, 3, and 4, 2, 3, 4, and 5, these zones that these units served, the dispersal volume was acceptable, but it was only indoor unit 1 that was too small. Because conceivably, if you had a leak at indoor unit 1, you could lose the entire system charge. So if the entire system charge could be released safely into the other zones, we don't need any type of mitigation. However, for zone 1, we said that we will. And generally speaking, the smallest zone will follow the smallest capacity unit. Of course, not always, but for discussion purposes here. So now to determine our maximum releasable charge when this valve closes, we are looking at only the downstream length of piping for our liquid vapor and the indoor coil, and some for the shutoff valve kit itself, which we will talk about. Now, we also have the ability to do a partial combined, so we can group indoor units. So as we'll see, again, it's a repetition of the same things that we have learned already. Now, first of all, what we want to do is group the indoor units together. Let's just say, for example, these two indoor units are going to be serving the same zone. How the units are grouped is exactly the same, whether it's R32 or R410A. So we are familiar with this combined indoor unit icon, right? So we can go ahead and combine those units, and when we click the icon, it will magically restructure the refrigerant piping. It's the same amount of separation tubes, but it just restructures the piping to what you see here. Now we can go ahead and go to the wiring/options tab and select our LDS. So to recap at this point, since we know that both indoor units are piped together, and in this example, assuming they are serving the same zone, once we are at the piping option screen and then the option selection, we'll see that we can go ahead and assign, or should I say select, the shutoff valve kit, the gas sensor kit, and expansion kit to either of the indoor units. We only need to select it for one indoor unit, and it wouldn't matter which one at this point. Continuing back to our piping screen, and similar to how we combined indoor units from a piping perspective, we can also combine the shutoff valves. Now you'll see a new set of icons here. So in the upper right, you'll notice that we have the combined shutoff icon. What we would do is select the two indoor units which we want to group for the shutoff valve kit. If you notice, the shutoff valve is only serving one indoor unit. So through the magic of Design Simulator, we'll select again the two indoor units, select combined shutoff, then take a note at the position of the shutoff valve, which moves from the single unit. Once we click the icon, it will switch over to the other side of the separation tube. Upon a leak from either one of those two indoor units, if the shutoff valve were closed, it's going to shut off and isolate refrigerant to both of those indoor units. Now we can make sure that we enter in all of our piping lengths. We can go back to the room setting function if we wish to use that, and we can determine if we, make sure that see if the compliance measure worked, and then we can estimate our maximum releasable charge here. If we want to do it manually, we can do that. estimate the max releasable charge and compare it to the room volume. What about MREL calculation? As of this writing, as of this presentation, Design Simulator does not have the ability to calculate the downstream refrigerant quantity, but that is in the works. So what I want to show you is how it's done through the ASHRAE standard 15.2, which the results are very similar for ASHRAE 15 as well. So what's the scope? What are we trying to do? We're trying to quantify how much refrigerant could be lost if, for example, indoor unit 1 had a leak and the shutoff valve kit closed. What's that maximum releasable charge downstream of the shutoff valve? Well, it's the downstream sum of the shutoff valve itself, the liquid coil, or excuse me, the indoor coil volume, the liquid line volume, and the vapor line volume. So it's those four items that are somewhat subjective. They're objective, meaning that they're easy to quantify. Now we have a fifth, and I have it grayed out because it's not really practical to calculate manually, which is known as the shutoff valve closure time. So when you think about it, there's two components to that actually. It's how much refrigerant leaked from the time the leak occurred until the time that the refrigerant detector sensed that there's a leak. And then also how much additional refrigerant could leak from the time that the leak detector shut the system down until the shutoff valve closed, which is about 30 seconds for our shutoff valves. But it's a minimal amount. By far, the greatest amount of refrigerant is going to be through through 2, 3, and 4. And you could even say that number 1 is going to offset number 5, but we'll see. This will get us close. This will get us close. But again, it's the ASHRAE prescribed method that we're discussing here. So we have to factor for the refrigerant charge in the shutoff valve. So this is the additional amount that would be added based upon the model number. So if you think about it, if a leak occurred, we don't know exactly how much refrigerant would be lost because the shutoff valve, for example, if the valve were right in the center of the piping, you could conceivably say, take this value and divide by half. But we don't know this amount, so we will use the default value for the added refrigerant charge. So since we have the O27A in this case, we'll use 0.22 pounds of refrigerant. So that's number 1. Number 2 is the indoor coil volume. Now, ASHRAE has got 3 different classifications for quantifying the refrigerant, and that is the MU value for the indoor coil, and it's H for heating, C for cooling, and MUS for standby. So we look at these 3 values. So I'd selected MUH for heating because that's the greatest quantity in the heating mode. So when you think about it, the indoor coil is acting like a condenser coil, right? So that's why it's got the most refrigerant in there compared to, say, cooling or standby. So in this case, since we have a 4,000 BTU unit, we're looking at 1.42 pounds. And I have a little asterisk that this is subject to change again when the Design Simulator update comes out, where it can actually calculate MREL automatically. Now let's take a look at the liquid line. So I've got 2 different sources here, the D&T and ASHRAE, because I want to show you how close they actually are. Through our D&T and our installation manuals, we know that with our VRF systems, if we have a 1/4 inch line set, or 1/4 inch line rather, liquid line, our added refrigerant charge is going to be 0.013 pounds per foot. ASHRAE standard states 0.011 pounds per foot. When you think about it, that's a difference of 0.02 of a pound per foot, which is not very much. To extrapolate that out, a 50-foot line set, 50-foot liquid line with 1/4 inch would be, the difference between the D&T and ASHRAE is about 1.5 ounces actually. The 50-foot 3/8 liquid line is a difference of approximately about 4.5 ounces. So the amount is actually negligible. So you can use whichever one you truly wish. You could stick with the ASHRAE standard, which would be a little bit lower, or you could go with the D&T, which is slightly higher, which again will be on the conservative side. So we know that we only have 5 feet in this example from the shutoff valve to the indoor unit. So 5 times 0.013 is 0.065 pounds. Now let's move on to the vapor line calculation. Now the D&T does not provide a volume for the vapor, thus we will default to the ASHRAE standard. So in this case, we see that we have 2/1000ths of a pound per foot, which again, vapor is not very dense, times the 5-foot section comes to a total of 1/100th of a pound. Values together, which is easy to do. So we said with the shutoff valve, we had 0.022, Ender unit heat exchanger, about 1.4 pounds, the liquid and the vapor. So it comes to when we compare the maximum releasable charge to the total MS, the total system charge, it's substantially different. So now, if conceptually, if we had a leak on indoor unit 1, we would only leak less than 2 pounds compared to if we had no mitigation measures whatsoever, no LDS, we could conceivably lose the entire refrigerant charge in that space, 10 pounds, 10 plus pounds. So as you can see, now we have a significant reduction in the releasable charge. So this is fantastic. So again, you may or may not need to do that to the other zones. Again, you can perform the dispersal volume calculations manually, or you can use Design Simulator to assess. So Design Sim should be used for every R32 system, as well as the load calc. We want to make sure that the equipment is properly sized, properly applied. I have in red here, it's a basis for ASHRAE safety standard compliance. This is critically important now. And it's a permanent record for you, for your customer, and also your authority having jurisdiction, or AHJ. So if your inspector says, I need to see your calculations and how you came up with this, you can easily give them copies of your Design Sim report so you can show your work, for example. Infinite what-if scenarios, as we talked about, as far as comparing and making sure that we have correct indoor units by capacity on the correct ports for multi-zone, as well as our J-series small VRF. And it helps avoid costly errors. Again, you can create a Design Simulator report in minutes, and you can save potentially thousands of dollars of corrective action for an error afterwards, as well as many hours of frustration. So it's a sales, you can use Design Sim as a sales tool, in my opinion, to differentiate yourself from your competition. So you can use this if you're a distributor. You can you could even teach your counter sales people how to use the software, and again, in literal minutes, you can have a full-blown report that you could print out, hand off to your contractor, or as a contractor, you can, during your presentation, you can show your customer that you, for example, we do load calculations, we make sure the equipment is sized properly, we make sure that we run our projects through Design Simulator to ensure we have the correct refrigerant lines and that we know exactly how much refrigerant the system takes. We will have a permanent record of it, and that can be used again for permanent record, for using in terms of permits, but it also instills a sense of confidence with your customer. What about resources? We've got a Design Simulator download, which is the most up-to-date version right now. We will be having some Design Sim tutorials that talk about the individual steps that we just discussed today in more bite-sized application instead of one lump sum in a 50-minute time period. We have also got some application resources. We have a few outstanding documents. To start with, we have the ASHRAE standards application guides that cover 15, 15.2, and 34. This is a phenomenally comprehensive document authored by our senior applied systems engineer. Granted, I have some input into that as well, but it was actually Leonard's brainchild to take the ASHRAE standards and condense them into something that's much more readily understood. And we have the ASHRAE 15.2 quick reference sheet. Internally, we call that the cheat sheet. This is what I alluded to at the beginning. That's got the Mmax, our max refrigerant charge, based upon our different dispersal area and heights. And then this is also the same document that has the factory pre-charge amounts, as well as the max pipe length and the max total refrigerant charge. I honestly think that, again, this is a great document that every installer should have, whether it's laminated. permanent record inside the installation trucks. Every installer should have a copy of this to make sure. And also, we talked about this before. We've got, if you were to use an existing line set, whether it's single zone or multi-zone, let's take a look at a single zone example. Let's just say you have an AUH 12 KZAH or XLTH. We see that the required line set is 4/3/8, and you can say, well, we have a clean line set, existing line set. It's clean, we're good, but it's 3/8 half. Can I do that? Can I go from 4/3/8 to 3/8 half? Actually, in this case, you can. However, note that due to the larger liquid line, the pre-charge length is reduced, as well as the additional charge per foot is increased, and the maximum length is also reduced. So it can be done. It's just important that you take note as far as what the revised limitations are. Now, each case is going to be a little bit different. I'm saving the best for last. We have an online 3C, what we call the charge compliance calculator. This takes the entire standard 15 and standard 15.2 and condenses it into a simple user-friendly interface that's got some simple text entries, as well as some drop-down boxes here to select the refrigerant. It's compatible with R454B, as well as numerous other A2L refrigerants. So here you can enter in your system charge, your occupancy classification, your dispersal floor area, dispersal floor height, move on through, and it will give you instant answers as far as whether or not the refrigerant charge is compliant. And it's got a printable report, so you can export this to a PDF. So again, this is accessible through the tools, depending upon your layout within Access. So it's tools, charge compliance calculator. So marketing will be having an announcement on this probably within about the next week. So this is an example of the printable report, which again can be used for permanent record to make sure that your system charge is in compliance with the standards. And for example, if you're pulling a permit and you've got some inspector or inspectors that are savvy, that have caught on to this, they're informed and they want to see your work, no problem. You can hand this to them and you can tell them, you can provide proof that the charge is in compliance with standard 15.2. So this is the money right here. This bottom paragraph here. It says calculated releasable charge is 5.8 pounds. The max charge based upon your room dimensions is 8.8. So you're actually 3 pounds under. So the charge is in compliance. That's what we want to see. So we've got some great tools for you to assist through navigating what seems to be a complex process. Thank you so much. We'll go ahead and open up the phones and take questions. We appreciate your time today. We realize you do have a choice, and we hope that today's presentation is helpful for every single project from today moving forward. Thank you again. Have a wonderful day.